Hello students, let us solve a problem from NEET UG Paper 221. Here is the problem. The problem says a capacitor of capacitance C is connected across an AC source of voltage V, and that is given by V is equal to V0 sine omega t. The displacement current between the plates of the capacitor would be given by one out of these four options given here. You have to find out which one out of these four is the correct option. So before we solve the problem, let us understand the problem itself. Let us consider a parallel plate capacitor, the plates of which are connected across an AC source of voltage V is equal to V0 sine omega t. Again, consider that the spacing between the plates has width d, and each of the plate is having area of cross section A. Now, since the plates are connected to this AC source, the plates will be getting charged, and hence there will be a uniform electric field in the space between the plates. But since the voltage is changing its direction and magnitude periodically, the electric field in between the plates also will change its direction and magnitude periodically, and this is the origin of the displacement current over here. So the displacement current arises due to time varying electric flux, and the displacement current can be given by id is equal to epsilon naught d phi e by dt. Now what is phi e? Phi e is the electric flux, and that can be written as phi e is equal to E into A. And at any instant of time, the electric field in the space between the plates can be given by E is equal to V by D, that is V0 sine omega t by D. Now, combining these two equations, if we find out phi E and if we plug this phi E in this equation 1, then what we get is id is equal to epsilon naught d dt of A V0 sine omega t over D. Now, this A, V0 and D, these are constant term independent of time. Then you have to perform derivative over sine omega t alone, and we know what we get from there is omega into cos of omega t. So we get overall this term. Now look, this first term, this term is very much known to us. This is actually the expression for capacitance for an AR capacitor. That means parallel plate capacitor having this A area of cross section and D is the spacing between the plates, and medium in between is air. So we can write this term as C, and hence we get the answer id is equal to V0 omega into C cos of omega t, which is actually matching with the first option. So this is the answer for this problem. Thank you very much.